Number 32, which of the following species is amphoteric? So amphoteric means that something can act as an acid and a base. So water, in the autoionization of water, is acting as, well, this first one is gaining an H, so it's acting as a base, and it gets it from this one, which is losing an H, so it's acting as an acid. Now, it doesn't have to be doing this with itself, of course, but it has to have the ability to gain an H and lose an H. So if we look at our options right away, of all of our options, we can definitely rule out B, because it does not have the ability to give away an H, so it can't be an acid, because it doesn't have one. All the others seem to work okay. C can definitely gain an H, because it could become like D, right, if it gained an H, and it could lose an H to become like B. So I think C is going to be the correct answer here. So D, the reason it can't be, it can behave as an acid, of course. It could lose an H, but it can't gain an H because there's no such thing as H3CO3. So definitely the answer is going to be C. 33. How many liters of distilled water must be added to a 1 liter of an aqueous solution of HCl with a pH of 1 to create a solution that's a pH of 2? So I think we're expecting that as we dilute it, the pH is going to go up, right? That's less acidic. Now, what they're trying to get you to remember here is that each unit on the pH scale is a tenfold change. So 2 is 10 times less acidic than 1. And if you realize that, then you're going to have to dilute this 10 times. So you'd have to go from 1 liter to 10 liters. So the answer is going to be D. Okay, let's try 34 again. I'm on hall duty. I messed it up a minute ago. A 1 molar solution of a very weak monoprotic acid. It has a pH of 5. What is the value of Ka for the acid? Well, let's do an ice table and equilibrium expression and see what we learn. So there they are. Now let's fill in the values we have. We knew that this acid was 1 molar in the beginning. And since we're trying to find the Ka, we can't have all X's in here. We have to actually have numbers. And so this is going to be an ice table where we do know the equilibrium concentration of one of these 3 things. So from the problem, based on the pH, which of those 3 things will we know the equilibrium concentration of? Well, if you guessed H+, you are correct. pH is always a measure of equilibrium concentration. And if a pH is 5, then that tells you the H+ concentration must be 1 times 10 to the minus 5th. So let's put in 1 times 10 to the minus 5th. Since this is going up by X and that's going up by X, this has to be the same. And the 1 molar is going to go down by 1 times 10 to the minus 5th. That's like essentially 1 molar, approximately. So down here on the bottom, I've plugged in my values, and the 1 molar is just going to be 1, so we got to do a little math without a calculator. 1 times 1 is 1. Then we got to add together the exponents. Minus 5 plus minus 5 is minus 10. So it looks to me like the correct answer is going to be A. Number 35, they want to know, they tell us the value of Ka for this compound, and they want to know what the value of Kb is for its conjugate base. Well, you remember, you can relate the Ka to the Kb by doing Ka times Kb equals 1 times 10 to the minus 14th. So let's plug in the values and do some math. Number 36 is a titration one. So remember, a great way to tackle titration questions is to use MV equals MV, especially in multiple choice questions. We need to be a little bit careful though, because let's see, we can use 0.1 molar for the sodium hydroxide concentration. They want to know the volume, so we know the right side is 0.1, and then we just want to know the volume that would be added. The concentration and the volume of the acid, well, the volume we know is 100 milliliters. We can leave it in milliliters. We just need to remember that we're going to get milliliters for our volume of base. And then for the concentration of the acid, I'm not going to use 0.2. Any guess why I'm not going to use 0.2? Well, the reason is because it's a diprotic acid, so I'm going to use 0.4 because there's 2 H's on each compound. And then, let's see, we got to do a little math. Let's set it up first, and then we'll decide which order would be the best to deal with things. So it's going to be like that, and 0.4 divided by 0.1 is 4, and then I just got to do 4 times 100, so I think the answer is going to be D. Number 37 is similar to one we did earlier. Which of the following species is amphoteric, which means can gain an H or lose an H, can act as an acid and a base. So a lot of times one of the best ways to tackle these is to consider what the possibilities. Like if HNO3 gains an H, it's going to be H2NO3. And of course, we've never seen that before, and it wouldn't work because NO3 is minus, this is plus 1, and it just unlikely. It could lose to an H to make NO3 minus, but to be amphoteric, it's got to do both. You can do the same with B. You can say, well, if it lost C2H3O2 minus, that seems reasonable. That's acetate ion. But could it gain one to become C2H3O2? And the answer is no. Acetate cannot pick up an extra one. C, I think, is going to be the answer because it could gain to make H2SO4. We've seen that before. And it could lose to make SO4 minus 2. So C is going to be the answer. Why isn't D the answer? Well, it'd have to gain to become H4PO4. That doesn't exist. And it could lose to become H2PO4 minus. And that's reasonable. So C is the answer. 38, they want to know if we add a certain number of grams of nitric acid in a 1 liter solution, what will be the pH of the solution? Well, whether this is going to be an easy or a hard problem depends on whether that's a strong or weak acid. It's a strong acid, so we're not going to have to draw an ice table. We're not going to have to do any of that. If we can just figure out the concentration, we'll be set. So we're going to take our 0.630 grams. We're going to convert our grams to moles. They told us the molar mass was 63 grams per mole. That was kind of nice that they did that. Whoa, look at that. That's a really nice setup. Now, how you might tackle this, it's up to you, but we could do it in scientific notation. The top one is 6.30 times 10 to the, well, we're having to move it one place, so we're going to say minus 1 divided by 6.3. The bottom is 6.30 times 10 to the, well, we moved it one place to the right, so it's going to be 1, and then that 6.3 divided by 6.3 is 1. We are going to subtract the exponents. Minus 1 minus 1 is minus 2, and so our answer is going to be 0.01 moles. And it's in 1 liter solution, so it looks like the answer is going to be B.